I'm sorry that it sounds like you guys are going to be boxing. You're not. I don't know. It's the box method. Anyway, so what I need you guys to do is you are not going to write anything right now. I'm going to run you through it. So that means put your pencils down, look up front. Okay? Watch this first. All right. The box method. Make sure you're paying attention up there, not on your paper. All right. So H2 plus O2 yields H2O. So we're basically making a water molecule. Cool. Easy enough. We're not going to start by drawing that line down the middle like we just did. You're not going to be doing the counting thing right now. Okay? We're doing the box method, which means you're going to put every single compound, molecule, element, whatever it is, in this equation into a box. So you can see that up here. Again, keep watching up here. I'll even zoom in so you guys can see it a little bit closer. All right, there you go. What we did, we had H2. That meant we have two H's. So I went ahead and put HH and put it into a box. What that is going to stop you from doing is adding an H when you just want one H. You can't do that. You have to add the whole box. Okay? All right. We have two O's. I put it into a box. Then we have our squiggly line. So that's our link, our middle where we have to be balancing on both sides. And then we're going to have HHO. Okay, for H2O. Make sense? So that is your first step. Put everything into boxes. Then you're going to look across these boxes and you're going to try to figure out if they have the same number on both sides. So, again, keep paying attention up front. Don't look at your paper. All right, so what we see here is I just start from left to right. I'm going to say, okay, 1, 2 H's on my left side. Over here I have 1, 2 on my right side. So I'm like, okay, well that worked. That's cool. Then I look at my O's and I say, okay, 1, 2. I look over here and I say, oh, there's only 1. So I can't just write an O. That is not allowed. That is you messing with subscripts, and that's the one thing I told you you're not allowed to do. You have to add the whole box. Okay? Does that make sense, what I'm stopping you from doing? Okay? You have to add the whole box. So we would add this box here. Awesome. So now my O's are at least, they have the same number, right? But now what did I do with the H's? I'm like, uh-oh, I added 2 more. So I'm going to come back over to this side, and I can't just add random H's. I'm going to add another box. And then I'm going to check. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. Everything is good. Your last step will be counting these up, and then you're going to put the coefficients there. So 1, 2, there's a 2 in the front. 1, you can either leave it blank or put a 1 in the front. 1, 2, there's a 2 in the front. And that's going to be how we're doing this. Okay? So, now you can pick up your pencil again. You just watched me walk you through one. We're going to walk through one together right now. Okay? So we're going to write it right below it. Okay? By the way, what is the mole ratio for this one, this example that we just did? Not 2, 2, 2. Look at it carefully.
Oh, 2, 1, 2.
There we go. It's a 2, 1, 2 mole ratio. Good. Okay. Now, so this example that we're going to do, we're going to go ahead, so write this carefully with me. We're going to do aluminum oxide yields aluminum plus oxygen. So we're going to have Al2O3 yields, so it's going to break down, this is a decomposition reaction, aluminum plus oxygen gas, which is diatomic. So we're going to have O2. Okay? All right, we're going to be doing the same method that you see before or on top. So the first thing that you start with is we're going to put our molecules, everything, into their boxes initially. All right? So I'm going to go ahead and start myself out. I'm going to say, okay, how many aluminum should be in my first box? There's 2. So I'm going to go aluminum, aluminum. How many oxygens need to be with it? 3. So I'm going to go oxygen, oxygen, oxygen. I'm going to make the box. That box is closed. That means you cannot just pull from it. If you're going to have to add multiples of something, you have to add the whole box, okay? All right, cool. And then we have our squiggly, because that's going to be our balancing line. Okay? So looking across, we have aluminum. I'm going to put aluminum into its own box. And then we have O little 2. So how many oxygens does that mean? 2. So we're going to go O, O. Okay? Awesome. All right. So now we have it set up. Now we have to balance our pictures. So I'm going to start from left to right again. So I look right here and I say, okay, I have 1, 2 aluminum. So I'm going to look over here and say, oh, I only have 1. So I'm going to go ahead and add myself another box of aluminum. So I'm going to say AL. Okay, so now I'm like, okay, cool. 1, 2, 1, 2. Awesome. Then I'm moving over. I have 1, 2, 3 oxygens. But on this side, I only have 2. You add a box to the side that has less. You add a box to whichever side has less. So this one has 3, this one has 2, so I'm going to add another one of these over here. 1, 2, right? So again, you can't just add an oxygen. Wouldn't that be awesome if we could just add an atom to it? Yes, 10 times easier, but you can't do that. So now we're going to check. We have 1, 2, 1, 2, that's good. 1, 2, 3, 1, 2, 3, oh man, 4. So this side has more now. So we have to add another box to our left side, okay? So we're going to draw this same exact box again. A-L, A-L, O-O-O. Which ends up messing with everything, right? Okay. Whew. So now let's look at it again. We have 1, 2, 3, 4 ALs. I look over here, I only have 2. That's an easy fix. We can just add some more of the ALs. Right? Now I have 1, 2, 3, 4, 1, 2, 3, 4. I'm going to look at my oxygens. So again, we handled that. We added those in. Now I'm going to look at my oxygens. I have 1, 2, 3, 4, 5, 6. Looking over here, I have 1, 2, 3, 4. So again, 6 versus 4. We're going to add it to the one that has less. So I'm going to add in another one of these O2s. And I'm going to check them. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yay! All right. So our last step is we're going to count them up, the boxes, and we're going to put those numbers as our coefficients. So what coefficient is with aluminum oxide? How many? 2. Good. We have 1, 2 boxes. So 2. Over here I have 1, 2, 3, 4. So we're going to have a 4. And then we have 1, 2, 3. 3 right there. This would have taken so much longer if we had done it with the line down the middle starting out. Okay, so I want everyone to force yourself. I know it's a lot of drawing,